Hello. Thanks for everyone for sticking around. I'm very excited to show off some neat little hardware tricks that you can do with React. And the barrier is actually a little bit lower than you think. So I'm hoping that by basically confessing the entire creative process, that you might find a few helpful tips, or maybe it'll take some of the intimidation out of hardware. I hope that maybe this doesn't look too scary. We'll see. All right, so just a brief introduction, because I'm not the interesting part of this conversation, and there's a lot to go over. I'm currently an engineer at Namely, which is an HR startup based in New York City, Austin, and right here in San Francisco. And previously, I've worked with some of these fun brands as well. So almost 2 years ago, I started using React for almost all my front-end development. React knows how to make websites, and it knows how to do that very, very well. And once I got comfortable with making a simple website, I immediately wanted to know what else I can do with it. Also, I love it. Specifically, how could I use React with these toys? I've been tinkering with hardware like Raspberry Pi and Arduino for a few years now. And I've always tried to figure out ways to kind of bridge that gap a little bit for physical standalone projects. For example, previously I worked with a group of interns to build a mind-controlled version of Brick Breaker. Well, it ran at about 1 frame per second on a Raspberry Pi. It was awesome, and I learned so much from that experience. And as a caveat, and much to the dismay of most of my coworkers, my desk started to resemble a small junkyard. Pro tip for anybody who wants to get into hardware, you're going to need a much bigger desk than what you already have. All right, and that brings us to a little bit of a story time here. It's a story about my friend Jake. It was around the time that I started messing around with all this mind-controlled nonsense that one of my oldest friends and closest friends decided he was going to get married. I was ecstatic for him and his new fiance. The wedding was out of town, and I was very excited to see old friends and enjoy the beautiful LA weather. Jake and I have been friends for over a decade. We've been roommates. We co-founded an art space in our hometown of Buffalo. And we have so many fun memories. And finding someone that he loves and that makes him happy couldn't have happened to a nicer person. So this was all really exciting. Except at the time, I was broke. I could essentially afford a plane ticket to get to the wedding, and that was about it. While a wedding gift isn't the only thing that matters, it did make me feel a little bit uncomfortable that I didn't really have anything to offer my friend who was having one of the most beautiful moments of his life. But I did have a lot of this stuff laying around. Wires, unfinished circuits, a bunch of broken things, things in plastic bags. Surely I could figure out something to do with all of this. There had to be a wedding gift in there somewhere. So desperately, I began constructing, a talking music speaker because reasons. It took a matter of weeks to feel like this was not only a selfish gift, but it was a terrible idea. And I went to the wedding without a hardware toy. So I was real disappointed in myself. Why is a custom talking music speaker, though, special to anyone? Jake or his wife wouldn't want to use that, nor would they, Jake and his wife would not want to use that. That's all I got to say about that. There is no use for a talking music speaker. But I did really enjoy the idea of making them something nerdy and fun, a little bit of an extension of myself. Fast forward a couple years later, and I'm visiting them as a married couple in LA. And I'm sitting on their couch, and Jake and his wife come home. And immediately Sam and Jake jump on the couch next to me and immediately turn on the television to a DVR'd episode of Jeopardy. From there, we proceeded to watch a marathon of 3 episodes, with the 2 of them shouting the answers at the screen. They were obsessed with it, and I had no idea. I had no idea they were so obsessed with Jeopardy. But now I knew exactly what I wanted to build them. I wanted to build them an arcade version of Jeopardy, one that played like a DVR'd episode of Jeopardy, where you could fast forward through all the commercials, and something that was just fun and fast and quick. But I'm not a lawyer. So I don't know the repercussions of calling something an arcade version of Jeopardy. So to mitigate this, I decided to change the whole name of it to Jeopardy. Because that's a lot more fun. So what's a Jeopardy? Is it an app? Is it a website? How do you play it? Can it be fun? These are all things I had to figure out. So I started just by identifying what makes Jeopardy so much fun to watch on television. I mean, it's been around for like, I don't know, 200 years, whatever. So it helps to establish just some core values about the experience of watching Jeopardy. It seems silly, but that will help me get to what this thing actually is. So the first thing is a visual confirmation of knowledge, or lack thereof. I'm admittedly very terrible at Jeopardy, and I'm probably not alone here. Jeopardy is hard. When the occasional clue comes on the show and I actually know the answer, I understand the thrill of blurting it out with pride. So it was important to me that the game maintain that ability and that excitement. The game had to judge and respond to spoken answers. Typing out an answer on a keyboard or selecting multiple choice, that's not Jeopardy. And it has to be social and antisocial. I wanted to make sure the game could still be fun among friends or just to pass a little time on your own. And it needed actual buttons. Tapping on a flat, fragile touchscreen to buzz in seemed like an invitation for trouble, outside of it being kind of boring. I wanted giant flashing buttons and to hear a click when I want to answer. If players were competing to buzz in, they need their own actuators that function like a light-up punching bag. It had to be noisy and durable, two qualities that are not usually attributed to a touchscreen. And finally, it just has to play Jeopardy, whatever it is. Sam and Jake wouldn't mind me to ask them to download something or log into a website just to be entertained. It doesn't have to be able to browse the internet or check your email. In fact, if I can just have it do like a perfect round of Jeopardy, that's all it needs to do. And that didn't really sound like that would require a very expensive or fancy computer to do. Taking this all into account, I settled on just physically building it myself from scratch. This way, I can control all the hardware components that I needed. And here's how you do it. You just buy all those wires, and you hook them up. No, seriously. Well, let's actually talk about the real ingredients. First commit. All right. Well, the first ingredient is obviously React. That's why we're all here. React's going to actually power the Jeopardy board that will be displayed on the screen. We also have JService, which is just a delightful API that can return you actual Jeopardy questions that have been used in episodes. I don't know the legality of that. It's kind of clever. If you go on their website, they've made a program that just screen scrapes actual episodes. So I don't know. Talk to them about that, though. Don't sue me. There's also the Raspberry Pi. How many people here are familiar with Raspberry Pi? Oh, yeah. We all love Raspberry Pi. But basically, if you're not familiar with it, it's a low-cost credit card-sized computer that plugs into your computer, or plugs into a computer monitor or a television. So basically, whatever you're currently using to run your Reactified websites, you can do that on a Pi, and only for about 35 bucks. And then there is the Arduino, which will allow us to communicate with the buttons and the lights. And then Johnny 5, which is typically a robotics framework, that's going to glue it all together. It was important for me to keep this project in the realm of React, and that means I really didn't want to stray away from JavaScript. I don't want to learn anything new. I just wanted to stay just within JavaScript. And one thing about this framework is it's awesome, and I'll get to that a little later. And finally, we have Socket.io, which will open up a gateway for our React components on the client side to communicate with our hardware configuration on the server side. So that's a lot of stuff. But the main part we really want to focus on is just getting Johnny 5 and React to talk to each other and play nice. But before we get into configuration, so you can actually see how this game actually plays, I just want to do a quick demonstration. So I've got 3 contestants. One of them you're probably familiar with, Brent, and he'll be joined by another event organizer, Nick, and my homie, Clarica. All right. Is there a way we can get this mirrored up there?
Yeah. Hopefully.
Uh-oh. Let's see what I can do about that.
Looks really good. Great.
Yeah, trust him. It looks very good. Yeah.
Can you drag it to the other screen? Yeah.
Ah, there we go. Just zoom it. actual presenter mode. Cool. So basically, for just the demonstration purposes, I just narrowed it down to 5 questions that it will do well, maybe. It's also just, I'm just mirroring what's on my display. But typically, it's going to run on a Raspberry Pi and show up on the display in the actual physical unit itself. So just as a demonstration, we're going to have our contestants play the game. So the first thing that happens is they buzz in and select their buzzer. And I'll play Alex Trebek here. So it looks like the first person to go is Clarica. Which one do you want?
Let's do musical wood for 200.
200. Ooh. What is jump? No.
No.
That's pretty good. Anyone?
Anyone else want to get? No? All right, swing through the trees.
Jumps through trees.
All right, we'll try another one. Looks like it's Clarica's turn.
Still? Okay.
Yeah.
Let's do AKA for 400.
Ooh. Help out if you know the answer, just yell them out.
Hugh O'Brien.
There we go. You guys are about as good as this as I am.
Of course.
I'm going to try weather for 100. That seems like something we can
Weather
work
for
with.
100.
Oh, God.
Air conditioners. What is air conditioners? Oh, I've got that.
Hey, there we go. All right, smarty pants. Yeah, we'll stick with weather.
Yeah, weather's good. Mars.
The sun.
That's a good one. That's a good choice.
There we go. Another one. All right, last one. We'll do, I don't know. Okay, well, we're just going to stick with weather.
What is CO2?
Oh.
Carbon dioxide.
What is carbon dioxide?
Oh.
Try it again.
What is carbon dioxide?
Hey! All right.
That was mine.
So there we go. All right. You guys are
I
good?
think you need to fix your game. All right. That's right.
So yeah, that's how it essentially works. So yeah, Jeopardy is hard. Since it's using actual questions from real aired episodes, I think that that adds to the charm of it, is that it's really, really difficult to get a positive score on. Okay, so now that we've seen the demonstration, let's talk a little bit about configuration. So one of Johnny 5's strengths is the minimal amount of configuration that it actually really needs. And that's great when you want to get set up with hardware very quickly. There are really 4 main physical components to the entire game. There's the Raspberry Pi, and the computer, which is the computer that will run our game, a physical button for the contestants to buzz in, a physical light to provide visual feedback during the game, and finally, the Arduino, which will somehow get the light and button to respond and talk to the computer. So let's see how Johnny 5 sorts out this mess. All right, Jeopardy is merely a Node app running on a website through basically Chrome, or Chromium, which is basically just the Linux version. It's pretty unsophisticated. If you're familiar with making a basic Node app, this would be some configuration for your server or your entry file. So we all sort of know how that works. And we start by declaring we want to use Johnny 5 on the computer. From there, we define the USB port that it's currently plugged, that's the Arduino is currently plugged into. That tends to be, I guess, a pretty common one for most, like my laptop at least. It might differ for a Raspberry Pi. But that's just addressing just whatever the USB is. And then we tell Johnny 5 that there's actual buttons and lights hooked into the Arduino. And then there's the socket I/O side. Same idea. You just import socket I/O into your server. And then we tell, after that, when we tell Johnny5 that a button is pushed, socket.io should emit an event with an ID of pushed and a payload with a message in it. In this case, the message is stop pushing. And since Jeopardy has multiple buttons, I'm actually using this payload to kind of identify which button is kind of being pressed. And then after that, when it comes to lights, when socket.io receives an event named LED strobe, that should tell Johnny5 to start blinking the lights. All right, but wait a minute. Let's back this all up. What's all this stuff with the wires? And you'll notice that whole wire to the Arduino part is a little bit vague. And opening up the actual container for the game looks, a little intimidating. So here's just a quick crash course on making circuits. So basically, this is where it all started. This is actually the alpha version of the game. I knew that as long as I could get one LED to turn on and off and one button to register on the computer, the hardware side of things was pretty much hypothetically solved. I just need to repeat that process 2 more times for 2 more buttons and 2 more lights. And now it was kind of time to figure out, and also for determining where the wires actually go on the breadboard. It's actually not too hard to get started with figuring out basic circuitry, because Arduino's website gives you all the diagrams of what plugs into what. So if I want to know, what a resistor is, what it does, which one I should use, Arduino's website is probably going to give you a good rundown of how all that stuff works. And another spot where you'd find those diagrams is actually right on Johnny5. When you're actually referencing the Johnny5 API to get your app to talk to buttons and lights, right next to all the documentation is actual diagrams of how to wire up a button and how to wire up a light. So it's awesome. You could do everything all on one page. And if you're feeling ambitious, you can take that whole thing that you've prototyped on a breadboard and actually solder it all together and make your own circuits, which is exactly what I did. So I have a little scary brown box in there that looks like this. And that's all that is just housing a circuit that I've prototyped initially on a breadboard. But back to the software side of things. So with all my configuration in place, all the wires hooked up, it's time to actually make my React components do some new tricks. So the first thing that happens when you turn Jeopardy on is the lights go on, and it tells you to press any button to start the game. So let's see how we would make that work. Well, the first thing we want to do is make the light work. In this case, I just put it pretty much in my component did mount function. So essentially, I'm just declaring socket.io, and I'm declaring the client for it. And once I tell it to emit the name LED strobe, it's going to go back and reference that in my configuration and know to tell Johnny5 to start blinking the lights and give us that cool rave effect. And then responding to a button. Similar to how we set up our light, we can also tell our component to listen to button presses. So the first thing we tell our component to listen for, a specific socket event. In this case, we're looking for an event called pushed, because that's the name we gave it. We also need to define a handler function for this, so we know what to do with the payload when it comes. In our case, we're simply sending over a message. And for the handler, we'll just say we want to create an alert that prints the message every time the button is pressed. You can imagine other more practical uses for this, like changing the component's state. In my case, this is where I was actually hooking into the ID of the actual button. And voice recognition. This part is actually a lot easier than you think. Since the Pi will essentially be running a website on Chrome, there's a specific Chrome API for WebKit speech recognition. And it's pretty limited in the sense that it will only work on Chrome. And since the Raspberry Pi has Chromium, I don't really care about any other browser. As long as it can work well on this, that's fine with me. So this has a few callbacks. You'll notice some of the callbacks have The first one is on start, which essentially means do this thing when the microphone is actively listening. In this case, I'm assigning an imaginary function that we'd hypothetically use to make the lights blink. And the next callback we have is on result. And I'm using this to validate the answer. So basically, when the speech recognition component of Chrome determines that someone said something, this will go through and determine if that's the correct answer or not. And then our last callback is to turn off the lights. So when the game is done recording your answers, this just basically turns off all the lights. And then from there, we just tell it to start up. And that's pretty much voice recognition. I also include that link up there. That's Google's documentation about this whole API. Highly recommend checking it out. And then finally, we're just going to talk about construction and how I got to this wooden box here and some of the physical components. So for the container, and it's really important because I just didn't want to hand my friends over like a Tupperware container full of wires. I don't know how that transports on a plane. So this was bad enough. For the container, I decided on basically a paintbrush box for $30 on Amazon Prime. It was pretty simple, cheap, and sturdy. So I could drill holes in it, cut a spot for the screen. And it opens like a briefcase, which is really helpful when you need to repair your terrible soldering job. And I wanted the buttons to be dramatic and loud, so I went with a set called Big Dome buttons I picked up from an electronics store in New York called Tinkersphere. The fact that they also light up is just the icing on the cake. I had to swap out the power-heavy bulbs that came with them and replace them with LEDs because the Raspberry Pi isn't giving out a whole lot of power through USB, so the less strain I can put on the Pi, the brighter lights we're going to get. And I also needed a microphone, but I couldn't really decide which one, so I just panel mounted a jack so I can just take it out and swap it out with anyone I really want to. And that's basically plugged into, no, it's plugged into my computer now, but it's a USB sound card that just has an input and an output. And then for the display, I just chose the official Raspberry Pi touchscreen display. It's pretty easy to get up and running. I was real proud of myself. That's why I have the video up there of me turning it on for the first time. I felt like I was really going to screw that up or break it, so I bought 2 of them. But I only went through one. Mounting it was pretty easy. It just required a few measurements. But once it was in, it was very snug. And as far as my next steps are concerned, the roadmap, where do we go from here? Well, first things first, this thing needs a power button. Not a hole in the side where I can fish wires in and out of it. It's not for me, and the people who would be using it aren't going to be regularly opening up a box and trying to look for where a power cable plugs in. So I really want to build on a power button, and this way it can trigger the Raspberry Pi to safely shut down. It also needs better Wi-Fi. The Wi-Fi signal on here, the actual Wi-Fi piece is that big, and you can imagine it doesn't get the best signal. So I would actually like to extend that a little bit. The game does not work without internet. In order for Chrome to use voice recognition, it does need to ping back to their servers, as well as for retrieving the actual Jeopardy questions from Jay's service, that needs to communicate with an API. So I would like to upgrade the Wi-Fi just because it's useless without it. I would like a speaker, because outside of the clicks, it's pretty lifeless. I want it to like bzzz and make a lot of noises and be kind of obnoxious. And when I bought this USB sound card, it came with an audio out, so that seems kind of like a natural progression of things. And then optimization. One thing you'll learn about Raspberry Pi and running React is you'll need to do a lot of optimization. The game runs on a lot of timers, there's a lot of event listeners. You have to be pretty careful with this kind of stuff and really unpack it when the component unmounts. If you don't, the Raspberry Pi is not going to like you. And the first time I ever pushed code to the Raspberry Pi and tried to start up one game, as soon as I hit a button, the whole program would completely bomb out. So I had to do things like take the timer, all the different timers for all the different views of the game, and basically abstract it into a global flux pattern that would basically make sure that only one timer was running at a time, that there was only one event listener going at one time. This is probably a good time to mention that I have all the code for this up on GitHub publicly. So if anybody wants to help me out there, there's a lot of work still that needs to be done. But yeah, optimization needs to happen with this. And that's about it. Thank you so much. Thanks for hanging out. You can check the code right up on GitHub. Follow me on Twitter. I got like 30 followers or something. I don't really use it that much, so. But yeah, if anybody wants to check it out, let me know. I'm going to have this set up probably at some point during happy hour with it running on the actual Pi with the touchscreen. So if anybody wants to tinker with it or ask me questions, I don't bite. So let me know. Thank you.